So moving forward, macros. So macros, as far as I know, they came in very, very late into the process. And the reason why they came in is it was because of iterators. So whenever you, like in languages like C++ and whatever, you always have this thing of, you have a data structure, and then you have an iterator that you define that actually goes through that, so that you can have a generic way of passing things to certain functions, to sort, to print, whatever. But the thing is, to make these types, then it's a bit annoying. You know, it's a lot of code, and it's just a bit cumbersome. So he wanted to do something that was simpler, and that's why he needed the macros. And macros are pretty simple in the sense that basically when you're defining a function, right, you do something like this. So basically this is a function. Yeah, it's pretty straightforward. And to do a macro, you simply go like this. And this is now a macro. And so this is much better than the C++ macros because these have context. They're structured. You can use them. Basically, you can think of them as just functions. They can have stuff that exists in that scope, variables that exist in that scope. But basically, what's going to happen is that this is somehow going to be put in here, right? And because they're macros, and a lot of times you need to have this kind of functionality. So let's say that you have here some variable, yeah. And you want to print that, right? So you would want to go, okay, I want to. By the way, you can also pass arguments to them, right? But for now, let's ignore the arguments because this is going to be interesting. So now if I try to run this, it's going to tell me, well, it doesn't know this in this scope. In the scope of the macro, it doesn't know that this exists. So what you can do is that there's this little thing that is like a backtick. And what this means is basically grab this outside of the scope where you're being called. And this is helpful because then you can just, it's the same thing with the macro, right? You're just putting the code there, but you can still access stuff that is before. And if you go, let's say, int f word, and again, I don't know who knows this, but if you've watched the last one, when you call defer, basically what the compiler is going to do is going to put this code at the end of the scope. So if I just do this, oh, and let me just put it here like this. So what's going to happen is you get before called, right? Then you have f being called, and then you have the deferred being called. Deferred. And then you have the after. But if you do this, now it's referring to, it's saying, okay, you defer, but you defer in the scope of the caller, of the place of where you're being called. So this is pretty useful, and we'll see in the future in a bit just why this is interesting and why this is interesting to be used. But basically you can do something like this. Now, this all came along because of iterators, right? So he wanted to simplify iterators. And so, okay, so let's go, level 2, yeah? So when you're iterating about through something, like you have, let's say that you have an array of strings, yeah? let's say you have this, okay? So the way you iterate for something is you do for, you can do it something like this, and then you can go print, and we can go, okay, at a certain index, you have this value, right? And because of the way it works, it automatically will create these variables for us, right? So now if I run this, you know, you get hello world. And then they created something that is basically, how far can you go? What do you mean? With the backticks? At the moment with the backticks, you can only go basically out of the scope of the macro. He doesn't. He mentioned that he needs to think if it's really useful, but the idea is for you to not go overboard with this stuff. But you can have macros inside macros, but then if you do a backtick, you'll just go to the upper macro. And if you do 2 backticks, I don't think anything happens. Probably an error will happen, I'm not sure. But the idea at the moment is just, you know, this is like a last resort thing. Macros is a last resort thing. But the cool thing is that this is all steppable. You know, this is something that you're going to lose when you're debugging a macro. Maybe I can just do it here for the giggles. So let's see. Oof. Okay, so let's again, we need to have a main, right? So main level 1, right? So now if we go oop, and then we go oop, it's going to bring up this thing from Visual Studio. Visual Studio is going to load. Okay, and now if we step, let's see if this works. Yeah. So we have the breakpoint, then we have the print, then we can go. It goes into this guy because, and it even goes if I click F10, right? Because it's not really a function, right? And then if I keep stepping through it, you know, so it did that, then went to the print, then it goes out of the scope of the parent and it goes back there. So it's much easier to debug these things compared to what do you call them? To C++ macros, right? It's much better in that sense, right? Like when you get into C++ macros, it just becomes very problematic for you to understand what's going on and to debug it, and this just helps it. But anyway, so we have this, right? And they also added something that was, and again, I don't know if these things are going to be, yes, you should kill Lua. I don't know if these things are going to stay, right? But basically, so the for is basically something that iterates, okay? So they have this nomenclature that you can just go like this. And basically, okay, let me do it again. Oh, that's not what I wanted. I wanted this. So, you know, it's printing normally. And now if I go smaller, it's printing backwards, right? And I don't know if this nomenclature will keep, but you can also do something like this, equals true, right? So it's basically saying, do you reverse it, right? So if you pass here false, so you could have this coming in as an argument, and we'll even see a case of this being used, right? Also, another thing that they do is, okay, do you want to iterate by pointer? Because this is important. Like some situations, when you're going to have it is going to be whatever is there. So if it's an int, it's going to be that int. So if you change that int, you're not actually going to change the int of the array you're going through, right? So when you do it like this, right, now we're iterating, but instead of the it being the by value, what it's going to pass is a pointer to that thing, right? So now if I dereference it, you know, I have that. So the idea is, okay, you have this, pretty cool. So how do we make this generic, right? So for that, I'm going to maybe we'll even go level 3. because why not? So for now I'm just going to copy a bunch of shit because it's much easier. So let's assume that we have our own list, okay? So it's a linked list, and you just have the first node. You have a node of some type that is just, you know, it doesn't matter what it is. You have the previous node, you have the next node, and you have the first and the last on the list. So you want to do something that iterates through this, right? And in C++, you would create something that is like an iterator, and you'll do stuff, right? So let's say that we want to do, so we have this, we have a, you know, create the nodes, they're of type int, I'm putting some values there, I'm just, you know, doing the next whatever because I didn't want to create anything. So then what we would want is to do something like this, right? So here I would go print, and I want to print, you know, on position something I have, what? On position something I have something else, right? And it would be, okay, it's the IT index, because by default we're not defining it, and it would be the IT.value, right? Because the node has a value, right? And we're going to be going through nodes, in fact, through pointers to nodes, right? So what we want is something like this, but of course if you run this, it's going to complain for something else that I left. Right? It's going to complain that there's no for expansion. So here's where basically the macros made its place into it. So what they decided to do was that you can just have a way of defining how fors iterate, and you do this by creating something called for expansion, and this is a function, right? And the function will take something that you're going to define. So in our case, it's linked list, right? And then it's going to also take code, which is something special for macros. So basically, this is assume it's like a tree of code. Okay. It's also going to take two bools, that is the pointer and the reverse. So this is the thing that we used before, right? So that you can do, you know, this, right? And this is a macro. And so just to see that this is the moment is okay. So a few things now are going to come into play. I want to iterate through these things, right? So the first thing we need to do is, look, you need to define this IT, right? The default thing. And we're going to say, okay, the IT is going to be the list of first. Okay? And you're going to do the IT index is going to start with 0. And then you're going to go while IT, while it's not null, right? This is the same thing as going like different from null. You're going to go print, and for now let's for now let's just do this. So we're just going to do test, and we're going to go IT equals IT.next, and IT index plus equals 1. Okay? Now, what's the problem here? Is that we're defining this in the scope of the macro. So this is where the backtick comes into again. So you need to say, no. Actually, this thing exists on the scope that is being called from. It exists on the for, right? So you just do backtick, and you just need it to do on when you're defining it once, and then it's just, you know, you can just use it normally. So now if we go for, it's going to print test. Right? But the thing is, okay, no, but we want to print this, right? And this is where this thing comes in, because you can just say, okay, just go insert this, everything that is a hashtag, it's a compiler directive, so you can just say insert body. Okay, and now when you run, there you have this, right? Now, let's say that you go like, okay, for some, my list doesn't make sense to be reversed. Okay, I want to force it to always be, you know, forward. So you can just do something like at the top, you can just go assert reverse, not reverse, right? So this is fine, and now if I go like this, whoopa, now it's going to complain at compile time. Okay, you could also use this, which is at runtime, but basically whenever you can, just use it at compile time and it will fail straight away. Like it's failing on compilation, even though, you know, we're basically compiling and running at the same time. It's on compilation. But you can also go, no, you know what? I want to support this, right? I want to support reverse. Well, then we need to do something more complicated, right? So we need to go, for example, and this is again, this means at compile time, right? This is an if at compile time. So you go if reverse, you do something, else you do something else. Okay, so here when you're creating, you just go, okay, if you're reversing, just go through last, and again we would have to do something like here, like if reverse, else and for now we're just going to leave it as is. Like we'll assume, okay, the index is always going to be 0, 1 or odd because we don't have like that saved up, but basically it's printing backwards, right? And again, this is just, you know, and at compile time this specific one will compile into this kind of code, yeah, like this will be completely compiled, right? But if I use it again, right, if I use another one, that one will compile to something different, right? All at compile time, right? So it's not at runtime. We could also do this, right? But then it's the same code, right? So you're going to be paying at runtime for the if. So it's up to you what you want to do. And something that I also, one of the reasons why I don't like to use, what's it called, for eaches, is that once you're in a for each, you cannot remove something and you cannot insert. And here at the moment there's a bug at least that he needs to fix and probably will fix it soon. But basically you can do something like this, and what you're going to do is you're going to remove that item, right? But the thing is, okay, so you need to implement this. So the way this works is that you can just go here and you can just go remove is equal to, and then you put the code, right? So in this case you would have to go like, you know, it if, you know, if it dot previous different from not, or if it dot previous, then you have to go it dot previous dot next equals it dot next. You know, you have to do this kind of stuff, right? But basically it allows you to, you still have that functionality of, you know, iterating as if you're doing just, you know, from 0 to count -1. You know, still have that same kind of functionality. So this is pretty interesting, and you can also go something like, you know what, my code does not support this, so I'm just going to go okay, assert false, and at compile time it's going to assert because you don't support this, right? So if you remove this, right, it works. So to me this is much better in terms of for eaches compared to the support that we have in other languages. To me this is the thing that it's really making me use for eaches. Won't this get messy? In what sense? Like the fact that you have to define these for eaches? What depends. What do you mean? The fact that you're doing this? Well, but the thing that is interesting is that when you're doing this, you're actually putting here code. So you're actually, you're actually putting blocks of code, right? So, for example, if I go, but again, I think there's a problem here at the moment. I don't think this is going to work. But if I go like this, right? So it's going to replace remove with a print. So now if I go, yeah, that's a problem. So it's going to talk about this. So this is the bug that he needs to solve. For some reason, I think it has to do because of using the while, it doesn't work. But basically you could do, or let me try this thing, because I'm not sure if the break works. So see, with the break it's working. So whenever you call break, you're not actually breaking, you're just going to go, okay, test, test, test. Doesn't mean that you should do this, but it's the same functionality, right? So I think you can do break, insert, I think you can override break, insert, and something else. And the reason why breaking may be interesting to override is something that I will explain a bit later. It's nice, but it looks like it can be bad to maintain. What if you want to have remove and break? Basically, you just go like break equals this, right? And then you just go comma, remove equals some block of code. But at the moment there's a problem with this. For some reason anyway, he needs to fix it. Another thing that is, for example, fine, so you give up, yeah? Okay, fine. Another thing that at the moment is a problem is that, okay, this is nice and dandy, but for example, if I want to remove something in this list, I'm going to need to change these guys. But because this is like just a function in a way, these are being passed by value. So you would need to actually define something like this, right? And then you can change the list last and the list first when you do a remove, like if you're removing the first or the last. But this also has some syntax problem because it's because this thing exists. So at the moment, the only way for this to work is you need to for example, define the variable itself. So you go like this, right? And I think then it's going to work. Right, then it works. Right? If I just go like this, right, it complains because it's thinking that this is about that the pointer thing. But again, these things can change because it's syntax and whatever, but at the moment you need to do something like this if you want to be able to use this. And I'm not sure what he's going to do in the future, because what he was talking about was maybe this, whenever you're doing a for expansion, the first thing always needs to be a pointer to something and not just, it cannot be a value copy, right? And maybe that makes sense, because I'm not sure, like if you start thinking about, oh, removing things and whatever, it would be pretty weird that you can just remove things from something that you pass by value. So then you would have to go, okay, if you have remove, replace the remove with assert, right? So it would be a bit annoying. So I'm not sure what's going to be in the end. And let's remove this guy because we don't need this guy. Any more questions regarding this stuff? No, it just breaks like we were expecting. Oh, and by the way, this is a giveaway. So break, right, is this, but break IT means break at this level. Why is this interesting? Let's go back to the other one. Where is the other one? Debugging. Okay. So let's say we have here, but we don't want to do the debugging stuff. What we want is whenever you reach I is free and J is 0, you want to skip them, the rest of them. The free 1, free 2, free 3, free 4, right? You just want to skip them. So normally what you do is something like, or let's not say, you want to break. You just want to get out of this. So you would have to do like something like once break false, and then if this, then you go once break equals true, and then you break this one, and then you go here, and you go if once break, right? You'd have to do something like this, right? So let's just clear. This was J debugging. What am I doing? I'm not running it. So right, you need to do something like this. But the language allows you to just say which iterator you want to break. So you can just get rid of this, and you can just go, you know what, when you break I. So it's the same thing, right? It's pretty cool. And you can also say, you know, break J, yeah? If you want to specify, if you just say break, it's the first scope that it encounters, right? But if you specify, then, you know, it's the other scope, right? And here we just skip the other ones, right? And the same thing works with continue, right? You can just go continue I. So basically, you know, you're just going to skip all the other ones, right? So this is also pretty useful. Anyway, just a little side note. Oh, back to the other thing. Where is it? Macros. So you have this, right? But let's say that for some reason it's interesting for you to have different kinds of iterators. So think of if you have an iterator that is fast, that just iterates go to the root. I don't think there's go to here. I really don't know. Is there go to? It's something that I haven't like this is C++, 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 C++. I don't think there's go to. But let's say that you have something that you're iterating and you want to iterate, you know, the fast way. That is just you're going through the list however it is. But let's say that you need to go, oh no, I need to display something in, let's say, alphabetical order or descendant or whatever. So what you can do is you can create more of these, because this is like by default the for expansion. But you can simply go, or maybe not, let's just, you can go like this, right, and call it whatever you want. And here let's say that for I0 free print test 4, and then on the iteration you can just say and I think you have to define it here, you say like this. Again, this thing can become a bit weird. I'm not sure if this is going to stay or not. Macros. What did I do? Okay, makes sense. What did I do? It's complaining that it doesn't have the IT. That's weird. This in theory shouldn't need to be there. Oh, no. Sorry. Because then this guy does not exist, right? Here, see, we're creating them. We're actually creating them here. So it doesn't exist there. So we need to comment this out just for the sake of argument now. God damn it. Where's my... This guy doesn't exist. So basically, yeah. So instead of going through the elements of the list, we're just going through, you know, this. Four of these, yeah. So it allows you to just say, okay, I want to iterate, but with a specific iterator. Just see if this is working. Okay. And now the last thing I wanted to explain here is just that, again, you can also, let's go level 4. So let's say that you want to have a macro that receives some code, okay? So you can just go, my code is code, and this is a macro. Again, this stuff with the code I think only works in macro stuff. And you just want to go, okay, but now you have a different, something different, because basically here what you're saying, this is basically insert in the scope of where you're being called. So something that you want to do here, you need to go like this, insert internal. So you can do something like this, and then you can go, for example, f print hello, and basically, yeah, this code tree is going to be passed here. It's going to be inserted as the internal code of the macro, and then, you know, that gets executed and whatever. So it feels like it's pretty extensible, and again, just because you can doesn't mean that you need to do it or you should do it, but with a lot of this stuff of being able to create like random type, not random types, like types at compile time and whatever, so that you can do really interesting things, this is very powerful. And there's something else that we're going to talk about macros, but later. Yeah, stick around. Do you guys have any questions about this stuff?